Right, I have a spacer. There we go, that's what we were waiting for. And that just goes on that side. In fact, let's put it on rather than talking about it. So it just goes on that side, like that. Shifts the whole of the drive unit that way, which means when you put this plate on, there's actually space for it to be tightened down and for it to bite into the bottom bracket tube. So let's do that now. I'm just going to put it on loosely at first. These bolts, I don't think it would be too unfair to say, are not the highest quality. You can see the peaks of the threads have already been sort of worn away slightly by trying to get these in. I'm going to keep going with them for now, but depending on how they feel as I'm screwing them in, I might actually change them. So they're actually now holding the motor in place, which is really good to see because they weren't before. They're also just making the bike quite close to being perfectly balanced on the axle stands that I've got it supported on. So I'm just going to add a bit more weight to the back so we don't have any embarrassing tipping up. It's holding the motor in place, but I think the main way the motor is going to be held is obviously with the nuts, clamp nuts that are going to go on there in just a moment, so we'll come on to that next. So these are the two we're talking about. That's the inner one that goes on first. That's obviously more chunky, that's made of steel, and then we've got an aluminium outer one. They've both got the torque settings printed or etched onto them, so 50 to 60 Newton meters for the first one, and then 25 to 30 for the second one. I took the opportunity to buy the tool that is an option with this motor or with the kit. Don't really need it for that end because that end's the same as a standard Holotech bottom bracket tool, which I've already got. But that one probably quite useful for doing this one up, although of course you can't use a torque wrench with that, so just going to do it by feel. I'm going to put a little bit of oil on this. So we can get a nice even torque rather than it sticking on against that metal bracket. Back that off a bit more, work the oil in, that's better. Just felt as if it was grabbing as I was doing it up. And this spanner is an absolute pig to line up. That feels good to me. Obviously I'm going to check the torque on these after it's been used a little bit. Put the cranks on. So I'm going to install the rest of the chain line stuff and then the new chain. Just a word about the idler wheel here. Putting the spacer on that motor and also just having the motor installed at all has moved the whole of the chain line out. So the run between the motor and the idler wheel is shorter than between the idler wheel and the cassette. So I figure it would be a good idea to actually stand this off a little bit. Can't put more washers that side because it's got a little lug on it, so that needs to engage in the frame. But what I can do is put some more washers here to bring this pulley out. What I'll also then have to do is use the same thickness of washer on these, the chain tubes which go on here, to bring those out as well. But that shouldn't be too much of a challenge. There's a little bit of space on that bolt to be able to do that, and if not I can add some new bolts. I've got a longer bolt. There's the washers I'm going to use, as you can see, and I've got a longer bolt to replace this one if needs be. So I know I've added at least 2mm with that spacer, probably another 2mm, that was my estimate, maybe slightly more with the just installing the motor compared to the standard chain ring. So I think these washers are about 1mm each, so I'm going to try 4 of them to start with and see how we get on. We can adjust it depending on how it feels and how it looks when everything's in place. So it looks like 3 washers is what we need. I prefer to use the original screws that came with the bike, but they aren't long enough. So we'll use these others instead. Unfortunately, can I get this on without taking everything off? Yes. So unfortunately these are a standard screw thread, screw head rather than an Allen one, which I don't really like. But they will do the job for now. We can change them later if needs be. And the camera is exactly where I need to be. So I'm just building up the chain. I found it quite difficult to find a chain for sale by the meter or by a certain number of links, whatever, i.e. off the roll. And I didn't really want to buy a whole roll because that's far more chain than I would get through in a reasonable amount of time. So what I've ended up doing, as you can probably tell, bought 3 chains. This is KMC X9. This is the EPT version, which supposedly has a lot more corrosion resistance. I haven't used it before. But I thought it was worth a go because the previous chain did get quite corroded. These chains, because it's a 20-inch rear wheel, they're pretty close to the ground and they get a whole load of hammer, especially because this bike's used in all weathers, so I felt that the small extra expense was worth it. So I'm aware obviously that joining 3 chains means you have 3 joints with 3 opportunities for failure, I suppose there. I've found these missing links pretty strong in the past. I've not had one fail as long as they're installed properly, so I figure that's okay. It'd be ideal to buy chain off the roll or use chain off a longer roll and only have 1 link, but that option wasn't really readily available. Try not to get bits of glove trapped in. So there we go, that's 1. At this point I'm going to thread it through and then see how much chain we need. We might not need as much as the bike had on it because the chain that it had on it was obviously spec'd for having the 3 chain rings on the front, and we've only got a single one now. So I'm going to feed it in and actually measure it once we've got the wheel installed and stuff like that. So that'll be the next thing to do. Well, I've broken my chain tool, but aside from that we're doing alright. I may have made this slightly too long, but I'd rather go again and take another link out than have it too short. But that is too slack. That needs another one out. That's better. Happy with that. Bit of spare chain should we need it. Hopefully we don't. So I've got the chain in. just tested the drive line and stuff to make sure it's okay, and it seems absolutely fine. I just thought it would be worth showing you the drive line and how the chain's routed. So you can see that the chain line from the motor down to the pulley wheel, I think that's pretty good, that looks pretty straight. Then if we come further back and look at this, obviously it's in the easiest gear at the moment, so the most leftward position as we're looking at it now. And I don't think that looks too bad in terms of chain line, so I'm quite pleased with that. I'll take you close in so you can see what we've done. So we've got some washers there spacing the pulley and the upper chain tubes out. The lower chain tube, I decided it didn't really need it because that's not under tension like the upper ones. So after the chain, the next thing I'm going to do is the gear sensor. So that's this. Don't know if you can see, the cable goes through that hole down the middle for the rear derailleur, and so as you shift it senses that the cable is moving and it cuts the power. There's plenty of space with that wire there to go across to the other side. So I think I'm going to try and put this just here. It means I need to cut the cable sheath and cut a little piece out of the cable sheath. So I'm just going to mark where the first cut needs to be. Do you know what, I might just cut it once actually, because I think a bit of extra slack in that cable sheath wouldn't be an issue. And again, rather have to cut up more out later on than have to go and buy a whole new sheath because I cut too much. I'm undoing this just to get the sheath out more easily because it's kind of locked in against the handlebar grip. That's the only way you could get this in with these bar end shifters. So that managed to go about 2 meters, not bad, not bad. Hasn't actually squashed the surround too badly at all. These are pretty sharp, Barco 2101G, pretty good set of side cutters. You could saw it as well, but then you get a whole load of crap in the inside the lumen of the tube, which you don't really want. That ain't going to work. We need the cable in there to hold it all in place. Right, that's out the other end. So that now goes in there like that. And after all that, I think I'd probably prefer that to go around the other side of here so we can feed it all through that way at least. There we go. Yeah, that's better. That's better. Just trying to weigh up if it needs to be a bit shorter. Take it too far up there, it'll foul on the brake sensor wire. It just seems a little bit long at the moment. Actually though, having done the full lock to lock, surprised that it wasn't almost too tight to use before, because that seems about right. So we're gonna stick with that for now. A lot of these things can be adjusted afterwards. I guess some of it's down to personal preference, and some of it you don't truly know the answer until you give it a test ride. Now I turn my attention to the wheel speed sensor. So that's the sensor. Slides in and out like that. I put a small screw in there to adjust the clearance. A little rubber pad there and some space for cable ties there. Obviously I'm going to use red cable ties because it's a red bike, why not? And then this is the magnet that goes on the wheel. So it's like an old school bike speedometer really, before GPS came along. But obviously it'd be best for this one not to have to rely on GPS. So I'm just going to mount up the wheel speed sensor loosely at first. I'm going to put it on a spoke on this side, coming to this side of the hub rather than the other side, and I'm going to put it opposite the valve so that it doesn't completely cock up the balance of the wheel. And why make life hard for yourself by putting it around there? And you can just spin the wheel around and have it on one of these. Probably have it on that one, I think. It's got some thread lock on. And the orientation of that spoke matches the orientation of the chainstay. We got a little target. Don't know if you can see that, so a little cross on the back, which is where this needs to line up with. And obviously I'm going to have the cable exit point going that way because that's the way the cable needs to go. That's needing to be a bit closer to the centre of the wheel so it doesn't catch this. But I think that's going to be good. So I'll cable tie that loosely in place. It's going to have to go. So where are the other options for it? The problem with that was that the cable ties are going to go on that bit and then they'll just loosen and it will slide down, which is no good at all. I could put it that way round, but then the cable is exiting the wrong way. Don't really want to put it on the other side because there's already enough gubbins on the other side. I think we'll go with that actually. I think we'll go with where we were. That's going to be alright. So before I make the final adjustment on this and screw it in, it's a screw that goes into plastic and it doesn't look like it's the type of fitting that would tolerate much undoing and doing up and adjusting. So I'm going to move on to doing some other electrics now, and then when we power this up we can use the LED light, which I presume flashes each time it gets the signal, and we can see if we've got it close enough, and then we can make the final adjustment at that point. Alright, so now I'm going to plug in the wiring harness, which is that. That will enable me to see, to work out, sort of do a first working out of how I'm going to route the cables, and then I'll be able to put the right length extension on for the wheel speed sensor. And then we should be able to get everything organised. So I just talked through connecting everything up and realised I hadn't pressed record. Great. Anyway, I'll tell you what I did. So the wiring harness extension is that piece. That's got the connector for the controller on it, which is a green one. It's got the connector for the throttle, and then on a standard bike it's got the connector for the two brake switches. What I've chosen to do on this bike, because the intention is that the gear sensor, because the gear would usually be close to the motor, whereas on here it's further away, so the gear sensor usually plugs in directly to the motor. But on this one, what I've done, and I hope it'll work, haven't tested it yet, is I've plugged the gear sensor, which is on that side, into this wiring harness, and then I've plugged the brake switch for the left-hand brake straight into the motor. I bought two extensions for the wheel speed sensor and I needed both of them. There's a little bit of slack but not enough to take one out of the loop, so I'm glad I bought two. So that's a meter's worth of extension in total. The remaining connectors here, there's a 6 volt for a front light. These lights that the bike has actually run off USB power, which is 5 volts, so what I'm hoping to do is to be able to sort of wire that up so that you can switch the lights on and off from the controller, which would be nice. And then the last thing I've got to do is extend the main power harness, because that isn't long enough. That's going to require some extra cabling, so I'm going to do that now. So what I've got is some 4mm square conductor cross surface area thin wall cable. It looks thinner than these, but that's because these are the standard thickness insulation. So because it's thin wall, although it can cope with the voltage, it hasn't got quite the abrasion resistance that this would have. So I'm going to put it in some protective sheathing as well once I've joined these. I'm going to join these permanently because where this would be, there's far too much water and mud splashing around for the connectors to go there. So I'm going to join them here, take them forward, and then we'll have the demountable connector further up. So as you can no doubt tell, I'm using these solder sleeves, which are heat shrink. You do it entirely with a heat gun, and there's a ring of solder in the middle. So I usually start them off on the low setting. and then hold it roughly in the position you want it until it's cooled down a little bit. That just means that the heat shrink sort of sets straight rather than at an angle. I can tell, don't know if you can, that the wire I'm using to extend the harness is actually of a much higher quality than what's on there from coming out of the battery, so we're going to be absolutely fine with this wire. It's tempting to rewire the whole thing, but that's maybe for another day. What I'm going to do now is put a second layer of heat shrink, and again this is the heat shrink with the glue inside as per the solder sleeves. Because of the voltage this is carrying, I want it to be obviously safe. So I'm using this expanding sheathing which can sort of squidge up like that to go over cables, and then you can pull it tight like that. The issue is you've got to get it all on. Obviously I'm going to join these cables. It won't go over those connectors even singly, or it might do singly, but they're joined together. By the way, yeah, these connectors, so they slide apart like that, and they've got tiny little wedge shaped grooves which marry up, so you can change the orientation in which they go together. So this, I've measured it, is enough for all of this cable joined like that, but it's all slid up there for the moment and it's doubled back on itself. I'm going to terminate the ends of it in heat shrink, so putting a piece of the heat shrink that I'm going to use on the end here first. Also on here then, we need 2 pieces of heat shrink to go over the solder sleeves. I think that's everything, I hope so. I'll just put this cable up tie on here to hold the sheathing back from pinging. But now it can ping away all it likes. So sliding it down towards this end as far as it'll go, then I'm going to poke every single fibre of this inside here if I can. It's not particularly easy stuff to work with. Slide that through like that. It's just to make sure that I've got this going along the cable as far as it will go. And we can heat shrink it in position like that. So, to the exciting part, let's connect the battery up and let's check that it all works. I think I mentioned at the start of the video, I've done that once already. So, strictly speaking, it really should still work. Didn't need that soldering iron, move it out of the way. Okay, exciting times. It's off the main axle stand supports. Obviously I've got the back wheel in the air to ensure that I can test the motor without the bike moving. I've measured the wheel circumference because we're going to need to put that in so that the speed sensor gets a plausible signal. So I just pushed the bike along the ground and measured the distance, which was 156 centimetres if you're interested. So I'm going to put the battery on now. Okay, let's switch it on. Now that is a strong start. I'm just going to give it a quick hey. Nice one. Something's happening. Right, I need to find out how to program in the wheel speed. Tired. The wheel circumference. Okay, so my mistake. It doesn't want to know the wheel circumference. It wants to know the wheel diameter, which in this case is 20. I misremembered it. I felt sure it was circumference, but not. It's diameter. So to put that in, we need to go into the password protected menu. So switch it on. Press both of these together. Press both of them together again. It's now wanting the password, which is 0512, and then the first menu we get to after that is the wheel diameter, which is 20. As I understand it, if I just let it cycle through or let it count down, it will eventually go back to the standard menu. In fact, it does it pretty quickly. You've got to be quite fast. There you go, you see it's done it already. So you've got to be quite quick.